let's go ahead and work through a couple of these. It's kind of making me nervous because I'm looking at the recommended assignments, and out of the 32 that are in this class, only 9 of y'all completed the recommended assignments, which is telling me we're not practicing at home. So please, 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 please be practicing in some sort of fashion. Okay. If you can only do stuff in class, okay, fine, knock it out. That's what this hour and 30 is for. Okay. So let's go ahead and start talking. Using a sleep tracking app, 2 parents track the length of time in minutes that their baby sleeps uninterrupted from the time that they put their baby to sleep at night until the baby awakes. The results for the first 16 days are as shown in the dot plot. The value of 119 is at what percentile?
44.
So there was a discussion on whether or not you should round up. If this is multiple choice, it's probably going to make you round up. If it is short answer, you want to kind of keep it at that 43.75. Okay. So you could say 43.75 percentile. Okay. If it was multiple choice, it probably would say 44. Yeah. Good. Okay. Which value is at the 75th percentile? What'd you get? 100 and 150. Okay. Is everybody okay on those two? Need to discuss anything? Okay. All right. On number 2. Sienna says the maximum value in any data set is always the 100th percentile. Do you agree? Yes, why?
It's below, is equal to and below that number in the data set.
Okay, so everything is equal to or below, less than or equal to that value. Okay, so percent of values less than or equal to the given value. That's what percentile actually means, right? We talked about that yesterday. And 100% of the values will always be less than or equal to the max value. Okay. You think back to the description of percentile. Max value. On here, complete the table. So we're going to fill in the frequency. What's the first one? 1, next one, next one, next one, next. Okay. All right. So how do we get relative frequency? What's the first thing we always have to do? The total, right? I think that's what both of y'all said. Sorry, I was listening to 2 different people. So what is the total? Okay, so out of 30, you're going to do each one of these things. And you're going to get the percent, right? Yeah, I know. It's been in here. I don't know how it survived a whole day in here. Okay, so you should get these percentages. Everybody good on that? Okay, now yesterday we talked about cumulative relative frequency, which means that we're going to take the previous and add it to the one that we're currently talking about. So for instance, there's nothing previous than this. This is just going to be 3.3. If we add these 2 together, that's going to give us 10. If we add these together, that's going to give us 20. If we add these together, that's going to give us 40. Add these together, that's 70. And then add these together, that's 86.7. Add all of that together, it should equal 100. If you don't get a 100 down at the bottom, you did something wrong. Cool? All right. What temperature interval contains the 40th percentile for this data? What temperature interval contains 40th percentile for this data? 75 to 80, right? And how do we know that? Well, if we look right here, it's that cumulative relative frequency. Got 40%. We okay on that? Okay. All right, go ahead and look at number 4. Go and look at number 4. Okay. Interpret the percentile of the MCAT score of 512. So they tell us that the lowest possible score is 472 and the highest is 528. Interpret the percentile for MCAT score of 512. So what is it? Okay. 83% of the MCAT scores for this year, I'm going to write down here, are less than or equal to score of 512. When you say interpret, you state the number, you put context. So what are we talking about? Okay, and then if we're talking about percentile, we're going to say less than or equal to whatever the score that they gave us. Okay, don't mess up the interpret part. It's what you already know. You just have to make it blatantly obvious. Okay. All right, create a cumulative relative frequency graph using the information provided. I'm going to do that in just a second, but I do want to go over 5A, 5B, and 5C. For 5A, what did you get? 55th percentile. Well, what about 5B? 34 pounds. And then what about 5C? You got 15? Let me scroll down. 5C. It says, if a pediatrician has 200 3-year-old boy patients, approximately how many will have a weight of less than or equal to 27.5 pounds? How much? No, this is asking how many patients. 20 patients are going to have a weight of less than or equal to 27.5 pounds.
What would be?
B was 34 pounds. Okay, so remember how we read these graphs is, for instance, this says the top 25%. Look on the side. You're going to see where 25% is and meet it at the graph. And then what number is that? Okay, so from here to what interval will that be at? Okay, approximately what is the lowest weight needed in order to be in the top 25% of weight for all 3-year-old boys?
What was it at the 75?
Oh, I'm sorry. Reading is fundamental. I was wondering why that doesn't work. This is the 75th percentile because it says top 25. I can read, I promise. Okay. So that's going to be 34 for that. 34 pounds because that's the number that's down at the bottom. Now for A, you're struggling with A, we're going to look at 32 pounds. So we're going to see where 32 is, meet it at the line, and that's going to tell us the 55th percentile. Everybody okay on that? Yeah. Okay. For your graph on 4B, it's going to look similar to this, but you're using the numbers from the previous problem. I'm sorry. Yeah, you're using the numbers on 4. So 4B, I'm going to try to give you the most accurate depiction of this. So when you draw this graph, first thing that you want to do is make sure that you put cumulative relative frequency. Okay, and down at the bottom, we're gonna label it score. Okay, and so we've got 472, and we're gonna go up by increments of 10. We're 82, we're 92, 502, 512, 522. And I think that gets all of them. Okay. So for 472, how many were there? So for 472, how many were there? 0. So we're going to start at 0. And you can go up by whatever increments you want on the side. We're going to do by 20s just to make our lives a little bit easier. Okay. What about from 472 to 482? How much do we have? Okay, pause. We're given this information. We're doing cumulative relative frequency, right? So that means that we're going to do what? Okay, so from 472 to 482, what is that percent? Okay, it was like roughly in there. Okay, what about from 482 to 492? Okay. Right, this doesn't add to 100, so what do we do? Say again. Boom. Okay, what about 502? What about 502? What's the number? Okay. What about 512? 83. What about 522? And hopefully yours looks a lot better than mine. And then eventually it will hit 100, right? Okay. They gave us the percentile already in here for each one of these numbers. Does that make sense? We didn't add these up because they gave us the percentiles instead. Each table is going to be a little different, so you need to make sure that you're paying attention to what is the table giving you, what information is given. Good. Like on the one before this, they told us to find the relative frequencies. Yeah. And then we had to find the cumulative averages. This one, they gave us the percentiles. Okay. All right. Okay, so we're going to put a pause on this. Okay, go ahead and jump into our notes. So can you curve the test scores? Can you curve the test scores? All right. So your teacher is considering 2 options for bumping up the test scores for Unit 1, but how would this affect the distribution of scores? So Unit 1 test scores from the previous lesson, there they are. The 5-point gift. Your teacher adds 5 to each of the test scores. Okay, so what I want you to do is take each one of those numbers and you're just going to add 5 and fill in those blanks. So for instance, 60 plus 5 gives me, dang, y'all are good. All right, 65 plus 5, 75 plus 5, 80. 77 plus 5, 82. 78 plus 5, 83. 39 plus 5, 84. 80 plus 5. And you're filling in that table as we're going along. 87, 92, 95, 98, 100. Why are these boxes so tiny? 102 and 104. Okay, so if I were like, yo, I'm just gonna give 5 points onto your grade, This is what's gonna happen. Well, we're gonna see if this actually like helps. Like we think it helps. Does it help? Okay, so compared from the original scores to now, what happened to our test scores? They shifted, right? So there was a shift to the right from here to here, theoretically. So let's go ahead and plot all of these that we just filled in. So we're plotting all of those that we just filled in. So there's one at 65, two at 70, two at 80, 82. There's two. Excuse me? How did Pandora just randomly turn on? It knows. Cool. So looking at the original, that's this first one, to the +5, we shifted up. And everybody can see that, right? Okay. All right, so what happens to the shape center variability when we add 5? What happens to the shape? Does it change at all? Okay, so it remains the same. What about the center? It's going to happen to the mean. Okay, goes up by 5. So increase by 5. What about the variability? How spread out it is? It's going to stay the same. Okay, really quick, I would like for you to find the mean of the original and the mean of the new and put it down here. And then I would like for you to find the old range and the new range. You can either do this by hand, or remember, you can plug this into your TI Nspire. If you don't remember how to do those calculations, remember, go to your little how to calculator page and it does the 5-number summary. You're going to have to create the list, do all that. It's good practice to do this because remember, on your test, I can't help you, right? Got to have that down. So go ahead and take a moment, find the mean and the range of the old and the new. All right, so what was the mean of the original? What? 80? Okay. What's the mean of the new? What was the mean of the new? 85. Okay, what about range of the old? 39. And then what are the range of the new? Okay. Good? Okay.
I wish my teacher would do that.
All right. On the next option, option 2 is to double the scores. Your teacher doubles each score. I don't think this would happen, but if you doubled the score on each of these, you're multiplying by 2. So let's fill in the table. So it's 120, 130, 150. Right? And create the dot plot for that second one. What happens to the shape? Okay, so the shape is the same. What about the center? What about the mean? What's gonna happen? Mean is going to double. So the old mean was 80. The new mean is gonna be what then? What'd you say? Okay. Range is also gonna double. So range of the old was 39. And range of the new was 78. Okay, so it's doubled. Now, this would be a horrible idea because then everybody is like over 100. So everybody gets an A. Okay, maybe it would be nice. Okay, go ahead and flip the page. Then flip the page. So we can see that the shape is fairly symmetric, right? Okay, the mean we already said was 80 and the standard deviation is 10. We're going to calculate the z-score for a student with a score of 93. Just a refresher, z-score from yesterday was the value minus the mean divided by the standard deviation. So what's our value here?
93.
Okay, and what's our mean?
80.
And we're going to divide by the standard deviation. And so that's going to give us 1.3. If you weren't here yesterday, that's what we learned. Okay, now suppose we want to convert all the test scores into z-scores. There are two mathematical operations needed to convert a test score into a z-score. You've got to subtract the mean from each test score and then divide by the standard deviation. Okay, so step one, subtract the mean from each test score. So looking at option one, I'm sorry, step one. What's the shape of this? Stays the same. It's fairly symmetric. What was the new mean on that one?
0.
Okay. And what's the new standard deviation? Okay. All right. Now step two, divide the results by the standard deviation. What does this do to the distribution? It's still fairly symmetric. The new mean is still 0. But the new standard deviation is going to be 1 because we divided it by 10. So given any distribution of the quantitative data, standardizing the distribution will result in a distribution with stays the same shape, the mean is 0, and the standard deviation is 1. Okay, then flip the page. So we're going to summarize this. All right, we're summarizing it. So you're going to draw this little chart. And this is for each one of these types of scenarios. Yes. And you're going to put shape, center, and variability. If we added a constant, what happened to all these things? This was the same, the center increased, and the variability was the same. If we subtract a constant, what's going to happen here? The shape is going to be the same. We're going to subtract from the mean, and the variability will be the same. If we multiplied by b, then the shape is going to be the same. The center is going to be whatever you multiplied by times that mean. And the variability will also be times that. If we divide by b, then the shape is going to be the same. We're going to divide by whatever that number is that we're increasing by. And the variability will also be divided by b. So again, this is called standardizing a distribution. That means that it's going to have the same shape. Mean equals 0, and the standard deviation is going to equal 1. Do you remember back in, let me take myself off of this. Hold on. All right, so take a look at the results. Tell me what you think. So the shape on all of them is going to be the same. The standard deviation on the first part is 4.998. The mean is 6.107. Questions on A. From days to weeks, we divided by 7. Okay. On part B, so the mean is 6.107. Yep. On B, it's the same shape. The mean is 5.107. The standard deviation is 4.998. So it's the same standard deviation as the previous one.
6 weeks is crazy.
You're supposed to change your sheets like every week. Or like, no. Yeah. People be out here like going, have I ever changed? Yeah, no, just kidding. All right. And then your part C is going to be, shape's going to be the same, mean's going to be 0, and standard deviation is going to be 1. So on part C, we're converting to z-score. That's why that mean is 0. Yeah.
The mean for B is,
yep.
That's a 5 or is that a 6?
5. Yes. Nova. So that's converting to z-scores. Yes. Z-scores is going to make everything comparable. Because like, remember how we did on that second part, we made all of our test scores double? Well, 160 is not comparable to 80 when we're talking about the data. So we're going to change them all to z-scores so that we have a distribution that shows it that is comparable. Does that make sense? Okay. Good? Okay, we're going to do something fun. Yay. Yeah. Okay, so it's just gonna be okay, so you said this activity, that first activity is going with this one. So it's a die. Okay. The first one goes with a stopwatch. Why?
Why? Because like, what's the like I don't think a lot of people would keep going too far left or too far past 5.
Okay.
It'll be a lot grouped within that middle of like 5.
Okay.
So that's what
I really hit it.
Okay. All right. What about this one? So the penny's gonna go with this one. Why?
Oh, because we learned about learning.
A lot of outliers. What else?
Asking if that was basic, what's the number range, what's really actually feeling closer to zero, like in.
Mm-hmm.
Cause like a lot of people make it close.
I mean, there was a lot of people who were in like the 40s, 50s range. Sometimes the coin kind of rolled, so like you really didn't have a accurate depiction of where it actually landed, because it landed and then it bounced off. So maybe there's a little bit of room for error. I didn't want to give you a ping pong ball because that was going to continue to roll. So, there was a couple of people who were in like the hundreds, but not a whole lot. Most of y'all were between like 50 to 100, right? Okay. I averaged. I can toss a coin. Okay, but yes, this would fall right in here. Okay, now let's describe the shape. Okay, so looking at this, what do we call it? Symmetric. Okay, is the mean gonna do what with the median? Is it equal to? Is it greater than? Less than? All right, it's about equal. Okay, we're gonna have a little bit of variation, just because of the 0.000 values. All right, what about the next one? Is this symmetric, skewed left, skewed right, bimodal, skewed right? Why? Okay, majority of your values are on the left or your tail is on the right, whichever way you want to say it. Okay, now is the mean greater than, less than, or equal to?
I got it.
Greater than. Why?
Joe, you messed up. Are you serious?
Because what? The bulk of the data is on the left. So this is because the bulk of the data is on left. Okay. All right. What about the last one? Okay. So we're going to say symmetric and uniform. Okay. Specifically uniform. Now, what about the mean to the median? About the same. Okay. All right, we okay on that? Okay, these are what we like to call density curves. I'm going to be perfectly honest. I don't think you've really seen, or I don't think you're really going to see that term that often. But this is just to show where the data would fall. Notice how there's no numbers down at the bottom. There's nothing on the sides. So this just shows kind of what the spread of the data would look like. Yeah. Okay. You don't really need to know that term, but it's there. Okay. All right. Looking at the data down here at the bottom for 100 students. Here's a distribution of stopwatches for 100 students. The mean is 5 seconds and the standard deviation is 0.1 seconds. Okay, so the mean is 5 seconds. What we're going to do is we're going to label this. Okay, so the mean is mu. Do you remember mu? It looks like a cool little N. Mu. Yeah? All right. Now, the standard deviation is how much? 0.1. So if I take 5 and I add 0.1 to it, what number does that give me?
5.
Okay, so this is going to be 1 standard deviation above the mean. So we're going to represent that with mu plus 1 sigma. I'm going to write that out to the side. No.
This is my 18th step, but it's very hard.
I say sigma 1 time, yo. I don't understand y'all's language. Like, I don't. I know that's bad. Good. I don't know. I don't know what it is.
You don't know who Skippy is?
No.
He's a guy that lives in the toilet.
It's just as bad. Let's see.
I'm gonna go home and try to relate to y'all and like look up all of these things, but I'm culturally not savvy apparently. That's okay though. That's okay. You know, if I brought up things from the 90s, you would know what they are. Okay. Now, if I take 5.1 and I add another 0.1 to it, what is that going to be? 5.2, which is going to be mu plus 2 sigma. Y'all ain't gonna laugh on that one? Okay. All right. Now, going the opposite way. Going the opposite way. What now? We can add 5.3 would be mu plus 3 sigma. 3 sigmas. All right. Now the other side, if we subtract 0.1, which is our standard deviation, we would get 4.9. This is going to be mu minus 1 sigma. So it's 1 standard deviation below the mean. Okay, if we subtracted another 0.1, we're going to get mu minus 2 sigma. If we subtract one more, we're going to get mu minus 3 sigma. Done. I quit. Okay, so what percent of the values are within 1 standard deviation of the mean? Okay, go ahead. 34 plus 34 is 68. Okay, 68%. You actually learn this in like algebra 2, and when I show you it, you're gonna be like, oh yeah, that's right. Okay, or whatever was called algebra 2. For 2 standard deviations, it's gonna be 95%. Okay, I'll show you the breakdown in just a second. 3 standard deviations is 100% of the data. Okay, it covers all the data. Okay, so 100%, that's the total area under the curve, which is 100%, also equals to 1. So when we describe the shape of this distribution, we draw like our little line. This is symmetrical. And here's a new word, approximately normal. Okay, so it's symmetrical and approximately normal because we are going to talk about the normal distribution curve. Have you heard of that before?
Yeah.
I think you've talked about it in algebra 2. Yes, the bell curve. We are calling it a normal distribution. So go ahead and flip the page. Let me give you some information that you probably already know. This is why we can't have nice things. I blame y'all. It's fine. Okay. Ready? Okay, so you're going to draw a curve. Okay, you're going to split it down the middle. Mu is going to go right there. Okay, we talked about mu plus sigma. It's not funny. All right. And then we talked about mu plus 2 sigma, mu plus 3 sigma. I'm gonna go look this up and then I'm gonna come back and have to give all of you a referral, right? That's what's gonna happen. No, no. All right. I don't wanna. Okay, so really quick. Okay, so you got 34 and 34% of the data here and here. Okay. Inside of this, that's 68%. Everybody good? Good so far. Okay, this is the percent of data that's within that standard deviation. Okay, just gonna let you know right now, these numbers you probably just want to memorize. It would just make your life easy. Okay. All right, these other ones, it's gonna be 13.5 and 13.5. So if we say within 2 standard deviations, that's from here all the way to here, that's 95% of the data. Okay. In that next section, it's 2.35. Okay. And so that means that if you go within 3 standard deviations, that's 99.7%. Now, all this little junk out here is like 0.15.
Same.
We rarely talk about that, but it's out there.
That it's safe.
Okay. All right. So density curves. We talked briefly about those. It means that the total area under the curve is going to be equal to 1. Okay. Area is proportion of values. And this is just a refresher. You've already learned this part. Skewed right is going to be like this. Ooh. And the mean is greater than the median. Skewed left is going to be opposite. And the mean is less than the median. Again, we've already talked about that, but just a reminder. Now, if you have symmetric, the mean is roughly equal to the median. Again, that's a review. Do you remember this curve? Yeah. Okay. You remember this curve, all this junk? Yeah. Okay. It's going to be really helpful if you know that. Okay. All right. So tomorrow we'll do the check your understanding. I need you to go ahead and start looking at the recommended assignments. Okay. They are already there. Get at least 2.1 done because we've already covered that. Okay. Go ahead and knock that out.